So we just came off this exercise with the Ferris wheel where we learned some interesting properties. We noticed that we could find the height using trigonometry and the understanding that the radius of the circle, at least on the left of the Ferris wheel, is 25. All right, so that was a real-life example, and I wanted to use that as a kickstart to our study on the unit circle. The unit circle, to the right, is where we're going to be spending a good amount of time over the next few weeks. So unit circle is called the unit circle because it has a radius of 1, and unit means 1. So we have 4 quadrants, and we're putting it on the coordinate plane here. And on the unit circle, you have just a couple basic properties. We're going to get into more properties as we go a little further into this unit. But for now, we've got the center is going to be at 0, 0 of the coordinate plane. The radius is going to be at 1. So that means every point on this circle, no matter where it is, if it's here, if it's here, here in quadrant 3, down here in quadrant 4, it doesn't matter where it is, any point in that circle is going to be 1 unit away from the center at 0, 0. Now I can take a ruler out and I'm just going to draw a ray here, because what we have there that you see already is an angle in standard form. I'll talk a little bit more about this in a moment, but for now I want you to be aware of some terminology. We always call this point here, this is standard form of an angle. It should always be on the positive side of the y-axis. So it's positive x there. So we have a ray that we call the initial ray, and that's too big for that. Hold on a second. So this first one that's on or in standard position along the x-axis is always called the initial ray. The ray that hits somewhere else on the circle, we call that the terminal ray. So the blue one there is the terminal ray. And we can go throughout the entire circle and we can figure out the degrees. Like that right there, that looks to be about 45 degrees. And looking at my ruler here, that is exactly the angle that it made. But let's take a look around some other benchmark points of the unit circle. Here is a 90-degree angle, and we can see that it forms 2 perpendicular lines right here, one on the x-axis, one on the y-axis. Notice that we start off at 0, 0. Now, if the radius is 1, then the point on the circle that will be straight at this 90-degree angle is 0, 1, right? Because you're not going anywhere on the x-axis, so that's 0, and you're going up 1, so the length of this right here would be 1. So this is at point 0, 1. Okay, now let's look at 180 degrees. Here you can see the terminal ray is on the negative side, on the left side of the y-axis. And this is another benchmark of 180 degrees. Now, if the center is at 0, 0, the length of the terminal ray is 1, right, because that's the unit circle, so the radius will always be 1. Then when the angle's at 180 degrees, it'll be at point -1, 0. The terminal ray will be pointing and going to and passing -1, 0. All right, let's look at the third benchmark, which is 270 degrees. And also notice the little drawing that I did here. I'm kind of proud of it myself. The little circle that shows you which direction it's going in. Because if it goes in another direction, we might see some different numbers. So once again, we have a radius of 1. And if it's pointing straight down, you're not moving along the x-axis at all, so you're at 0, and then you'd go down to -1. That's where the ray is going to pass through the terminating ray. Wait, terminating? I meant terminal. Sorry, I was thinking of the movie. That's the terminal ray. Oh, going from bad to worse there. Okay, terminal ray. Then we've got a full rotation, 360. Notice that this would be the same as 0, and if the ray is 1, or the radius there is 1, and we're going 1 to the right of 0, 0, we would have a point at 1, 0. That's going to be the same for 0 degrees. The only reason I know that this is not 0 degrees is because of this plate right there. That's letting us know we're making one full rotation, so that's now 360 degrees.